Okay, so here we are in the lesson 5, horizontal stretch and compressions. And when dealing with horizontal stretch and compressions, we want to look at the coefficient inside of the absolute value operation. And the coefficient is the constant, which I labeled as C here, but in our general form it's actually a B, so I'm going to write a B over top of this. The coefficient that's in front of the X inside the absolute value. And when dealing with that coefficient B, when it is greater than 0, unlike the vertical stretch or compression, when it's greater than 0, it's a compression, not a stretch. And when it's that constant B is between 0 and 1 for horizontals, it's actually a stretch. So we come down here and we plot on this graph. To explore this, let's start by plotting our parent function, as we always do. And we can see our parent function right here. Now let's plot our points. So at 0, we have 0 times 2, the absolute value of 0 is 0. And then if we put in positive 1, we have 2 times positive 1, the absolute value of 2 is just 2. We put in 2 for x, we get 2 times 2, which is 4, and the absolute value of 4 is just 4. If we put in negative 1 for x, we get negative 1 times 2, which is negative 2, and the absolute value of negative 2 is just 2. And if we put in negative 2 for x, we get negative 2 times 2, which is negative 4, and the absolute value of negative 4 is just 4. And if we come over here and plot these points, we get 0, 0 here. Then we get negative 1, 2. And then we get negative 2, 4. And we get 1, 2. And we get 2, 4. And keep in mind, we're looking at this in regards to the y-axis now with horizontal stretch and compression, not the x-axis. So if we look at it like that, we can see, with this right here being the y-axis, that this new graph is closer or compressed in to the y-axis as opposed to being pulled away from it. So when the coefficient is inside that absolute value, it does kind of the opposite of what it does when it's outside with the vertical stretch. Let's come down and explore more. Again, let's draw our parent function first. And then let's plot some points. Plug in 0, we get 0 times half, which is 0. Plug in 1, we get 1 times half, and the absolute value of half is just a half. If we plug in 2, we get 2 times half, which is 1. The absolute value of 1 is just 1. If we plug in negative 1, we get negative 1 times half, which is negative a half. And the absolute value of negative a half is just a half. And if we plug in negative 2, we get negative 2 times half, which is negative 1, and the absolute value of negative 1 is just 1. So if we plot these points again, we get 0, we get 1 half, and we get 2, 1, and we get negative 1 half, and we get negative 2, 1. And again, we're looking at this with regards to the y-axis, not the x-axis. So as you can see, when that coefficient is between 0 and 1, it pulls the graph away from the y-axis, stretching it. So if we were to describe both of these transformations, it's kind of opposite of the vertical stretch and compression. We would say with this first one, that coefficient, or this transformation, compressed horizontally, and we would say the second one, because it's pulling it away from the y-axis, stretched it horizontally.